All right, in this lesson, we are going to talk about linear quadratic systems, which means one of your equations is a line and the other will be a parabola. Okay, so we're going to have a line and we're going to have a parabola. Okay, and so we're going to start by solving these using graphing, just so you can see what your solutions will look like. Okay, and so starting with this quadratic equation, I can see that his vertex is going to be at 5, 1. And the a value is 1, which means I have a point that's over 1, up 1, and then my next point will be over 1, up 3. Just noticing the relationship between this function and the parent function. If you want one more point, you would go up 5 over 1. Okay, so the pattern in the y's go 1, 3, 5. 1, 3, 5. But the x distances are always going to be 1. Okay, this next one is linear. Our slope is 1. Our y-intercept is -2. So starting at -2, we're going to rise 1, run 1, rise 1, run 1. There's one of our solutions. There's our other solution. Okay, and so your solutions to any system is always where the graphs intersect. And so we have two solutions here. One of our solutions is 4, 2. And then the other solution is, looks like 7, 5. Okay, in this next example, we have our quadratic function. The a value is -1, so it's going to open upside down, but it's still going to have that 1, 3, 5 pattern. And then it's been shifted up 4, so the vertex is just at 0, 4. So start at 0, 4, then we're going to go over 1, down 1 over 1, and then down 3 over 1, and then down 5 over 1. 3. Okay, and then our linear equation is not in slope-intercept form, so I am going to subtract 2x from both sides. And so that gives me y equals -2x plus 5. Don't combine those. The -2 is your slope. The 5 is your y-intercept. So we're starting at 5, and then we're going down to right 1 for that negative. Down to right 1, down to right 1, down to right 1. It's important to graph every point, and you're noticing that in this particular example because we only have one intersection. Okay, we don't have another intersection. And so our one solution is the ordered pair 1, 3. And so anytime you only have one solution, that's called a tangent, a point of tangency. So this line is tangent to the curve. You talk a lot about tangent lines in pre-cal and calculus. And so that vocabulary will eventually be very important to you. Okay, and so how many points of intersection can a linear quadratic function have? Sketch each case. Well, we just saw an example that had two solutions. A line can intersect a parabola in 2 places. So 2 solutions. We also saw an example where our quadratic and our line could intersect in one place when they're tangent. And there's also cases where the quadratic and the line never intersect. Okay, in that case, there will be no solution. Okay, so you can have 2, 1, or none. Not infinitely many, because these are not going to be the same curve. One's a parabola, one's a line. Okay, here they're giving us the graph and asking us to write the system. And so I'm going to start with the parabola. The vertex is -4, positive, oh, just kidding. +2, -4, x before y. And then it looks like we're going over 1 unit, up 2 units. And then we're going over 1 more unit. And then our next point is up 6. So my 1-3 pattern became a 2-6 pattern. And so I know it's been vertically stretched by 2. So my A value is 2 here. And so with the vertex, that's my H and K. So I'm going to have Y equals that A of 2. And then my X coordinate was 2, so X minus 2 squared. And then my Y coordinate was minus 4, just using transformations to write that quadratic equation. And then for the line, the y-intercept is -4, so B is -4. And then it looks like we're going up 2, careful with this weird scaling, up 2 over 1. And so rise over run would be 2 over 1. So y equals mx plus b would give me y equals 2x minus 4. Okay, and so the solutions, it says identify the solutions, are this point of intersection and this point of intersection. And so just be careful with this -4 and this -4. The -4 for the line is the y-intercept. The -4 for the quadratic, that's not the y-intercept. That's the y-coordinate of the vertex. That always confuses a lot of students. And so one of my solutions is 1, -2. And the other solution is 4, 4. Okay, and so your solutions are always ordered pairs. And so now that we're about to solve these algebraically, remember that your solutions are an x and a y, an x and a y, and that's still going to be the case. And so how we solve these algebraically is using the substitution method. And I think it's easiest to make sure both equations are solved for y, or whichever variable is not being squared. We'll see some examples where the other variable, the y, is actually being squared, and then we would solve for x. Okay, and then we are going to substitute and set the equations equal to each other, and then solve our quadratic equation for the x values, and then we're going to plug those x values back in for our ordered pair. Okay, and so starting with number 1, they're both already solved for y. So if I use substitution, I'm going to either, I can substitute this quadratic expression for this y. And so essentially just setting the two equal to each other. Okay, and so now we just have a quadratic equation that we can solve to get x. And so our first step would to move 2x to the other side. And usually these are going to be factorable. And so to factor, we need two numbers that multiply to 2 and add to -3. That would be -1 and -2. So this factors to x minus 1, x minus 2. Okay, and so that equals 0. Using the zero product property, that means x equals 1 or x equals 2 would be the x coordinate of my solutions. Okay, so we only know the x coordinates. 1 is one of our x coordinates, 2 is the other. We have to go back and find the y's. And so you can use either of these equations. I usually use the linear one because it's easier. Either way, you're going to get the same value. So 2x, y equals 2x. In this case, x is 1. In this case, x is 2. Okay, and so y would equal 2. Y would equal 4. So when x is 1, y is 2. When x is 2, y is 4. And so these are my two solutions, the points of where this graph would intersect. And so if you're picturing it, you have your quadratic, you have your line. This point would be 1, 2. This point would be 2, 4. Okay, and so next, let's look at number 2. This equation is solved for y already, and so I just need to solve my second equation for y, and I would get -x plus 1. Okay, and so I'm done with this equation. I'm using this equation now. Okay, and so I can substitute this quadratic expression for y. So negative x squared plus 4x minus 3, essentially setting the equations equal to each other. And then now we can solve our quadratic equation for x. So I'm going to add x to both sides and subtract 1. And so that gives me negative x squared plus 5x minus 4 equals 0. Now to factor this, it's better to have a being positive, especially for factoring. So I am going to divide both sides of the equation by negative 1. Anytime you have an equal sign, you're allowed to do that. So that gives me x squared minus 5x, changes everybody's sign. And of course, 0 divided by anything is still 0. Okay, so two numbers that multiply to 4 and add to negative 5 would be negative 1 and negative 4. Still equals 0. So by the zero product property, x equals 1 or x equals 4. Okay, and so my solutions are ordered pairs, and we have just found the x. And so use either equation. I'm going to use this linear equation here, y equals negative x plus 1. Substituting 1 and substituting 4 for the x's. And so in this case, y equals negative 1 plus 1, which is 0. Y equals negative 4 plus 1, which is negative 3. So when x is 1, y is 0. When x is 4, y is negative 3. Okay, and so if you're picturing this, our quadratic would open down, and our slope is negative. So we have this kind of situation happening. And so this would be our 1, 0 point, and this would be our 4, negative 3 point. Okay, I'm going to do this last problem. Here, notice y is being squared. Okay, and so we don't want, this equation is already solved for x, and y is being squared. So you're going to want to solve this equation for x as well. Okay, and so this time we're solving both equations for x. So I get negative x equals 2 minus y, and then we have to divide everything by negative 1, which gives me negative 2 plus y. Okay, so using these two equations that are solved for x, we can substitute this quadratic for x. So y squared minus 7y plus 13 equals negative 2 plus y. Okay, and so now I can add 2 to both sides, subtract y from both sides to solve my quadratic equation. Okay, so now our quadratic equation has y as the variable, so we're going to get what y equals. And so same method, we're going to try to factor two numbers that multiply to 15 but add to negative 8, or negative 3 and negative 5. So this would factor to y minus 3, y minus 5. By the zero product property, that means y equals 3 or y equals 5. Okay, and so for my solutions, this time we have the y variable, so just be careful. These are in the y spot, and we are going to have to go back to find the x. I'm going to use this linear equation, x equals negative 2 plus y, to find the x. Okay, in one case, x is 3, in the other case, y is 3, and then the other case, y is 5. So I end up with x equals 1 and x equals 3. So when y is 3, x is 1. When y is 5, x is 3.